Okay, thank you for coming. Our next speaker on this track is Maxim Thax from Vuga. Maxim is a freelance software developer with history working on IDEs, web development and mobile development. During the last 3 years and a half, he's been working in Guga or Black Anvil, helping them develop mobile strategy games and also a small entity component system called Entitas. Today he's going to talk about validation for online games using deterministic simulation to prevent cheating and keep consistency between the mobile data and the server data. So let's welcome Maxim.
One should. Yes, it does. Okay, thank you very much. My name is Maxim. Thank you for introduction. Thank you for coming. I'm very sorry about very long and very descriptive title, but I couldn't think about anything else to make it. So this will be kind of my post-mortem of 3.5 years working on different simulation games at Vuga in the core studio, which now is known as Black Anvil's games. All right, so there is one concept which can summarize the whole concept. This is like the heart of it. And it is double entry bookkeeping. Like really boring, right? Who knows what double entry bookkeeping actually is? A few. But people who don't know it, it actually comes from accounting, and it's something which accountants do. They have basically 2 books, and they write everything, your expenses and your incomes, actually one time in one book, one time in another book, so then they can, afterwards, then it will be like actually, you have some revision, then you can show both books, and then everything should be clear. Okay? And it's the same with simulation games. Basically, we have client which has its own book, and we have the server which has also a book, and those books should be consistent. All right, so the agenda will be, I will talk about general introduction to the genre. I will speak about economy, asynchronous PvP, and real-time economy. Well, what is a mobile games? What is a mobile simulation game? Actually, it's a broad topic, right? But from my perspective, where I worked, and if you look at the app stores, it's actually basically just 2 genres. It's a casual farming game, and it's competitive farming. That's it. So competitive farming, I guess you understand what it kind of does, right? All right, so why do we need servers in the first place? Well, there are 2 main reasons. The first reason is we would like to have multi-device support, and with own backend, it becomes much simpler. Also, in the mobile space, it means that the odds are high that your user will switch phones during the time that they play the game. And this is much easier to do than if you have actually a backend which can just give them a different the game state and configs and so on and so forth. The second main reason is more control. We can do A/B testing on the game. So basically what we normally do is A/B test the configs and see if the balancing is fine. Then we can introduce new content quite easily if it's just basically on the server, it will be propagated. If we break something, but it's also easy to recover and migrate the game states of the users if we have a backend. And again, social aspects for casual and competitive. This means I can visit someone else, town, farm, whatever, right? And it would be much harder to do without a dedicated backend. How does it work in the nutshell? In the nutshell is basically we have a client which we start the game, and it's a start session, and it requests the config and the game state from the server. Then it sends stuff to the backend, and at some point backend sees like, okay, the client hasn't sent anything for a while, let's just stop the session and persist it to a database or whatever it is. So one question in the audience, should we actually send full game states? What do you think? Yay or nay? Depends on the policy, right? So basically, absolutely correct. If you have a casual game and you don't care about cheaters, then you can just send the full game state, because this is the easiest thing to do, right? But if you have a competitive game, if you send full game states, you won't be able to validate them. Like, there is no way of figuring out, okay, could this game state evolve in this meta or not? Right? The question of how often it should happen is basically how much tolerance would you like to have for users to lose their game state? Because the mobile phones can go offline, they can crash, and so on and so forth. So if you if you say I don't care, I will just send it on session end, and if they crash, then the user will lose 10 minutes of gameplay. It's fine. Otherwise, you have to do it frequently so that the user experience is quite nice. All right. There are two main concepts behind economy. And I'm stressing on economy because basically in all these farming games, economy is the most important concept that you have. And the first one is a contract. What is a contract? It's basically something which has a cost, duration, and reward. Okay? So from the user perspective, what you do, you start the contract at some point, and then it's done somewhere here, and then you can collect it. Quite simple. So what are the contract-based actions? Build a building, upgrade this building, plant something, craft something, train something, repair something. All the things which have a cost, duration, and reward afterwards are actually contracts. Okay, so we would like to send this contract command. And here's an example. You say, okay, the type is start upgrade building, and then you identify the building. Normally we identify buildings by its position, but you can also have an ID or whatever. Then we say start time, end time, cost from level to level. Is this a good example? What do you think? Not really, because there is some data which we actually shouldn't send at all. Like, starting from here, this data is redundant because we already have it on the backend, and we shouldn't actually send it if we actually ignore the config and validate on this data. Then it's an angle for cheaters to actually say, like, okay, I will end this action or this contract in 1 second. The server should know what time it should actually take, and this is a much better example of a contract command where you say, I start the upgrading building of this building at this start time, and I will just say, like, I end upgrade building, and I say which building. This is it. Less data, it's actually much better to send it because then you have a less data to send, and also there is a smaller angle for intruders to change something. All right, back to economy. What is a missing concept? What do you think? This other concept is even in every puzzle game and so on and so forth. Sorry? Not quite. It's resource generation. Like, for example, even in a simple puzzle game, you have life which has to generate over time, right? And how can people cheat with this one? It's actually quite easy. It's the easiest thing. If you have no prevention at all, this concept is the easiest to cheat at all. What do you think? Yes, you can just basically start generating, go out, switch time to 3 hours later, and then you have resources and you collect them, right? Simplest thing to do. So what you have to do on each time when you come into the session, you have to synchronize your time with your backend. Otherwise, again, if you don't care, lots of simple games actually don't care about this stuff. Where you're like, okay, whatever. But if you want to, if you care about it, please at least synchronize the time. Right, here is a typical example of a resource generation. In this case, it's for buildings. We generate something, and we say, like, okay, we started generating on this building with the start time, and we collect from this building time and amount. Why do we say time and amount? Can we reduce one of these things? What do you think? Potentially we could, but for this we actually need a deterministic logic on in there, because calculating the amount can become tricky because of a few concepts that we have, and it's basically capacities. I will run through them very quickly because I'm actually running out of time, so sorry for that. This is kind of no capacity at all. Do you know a game which does such thing? Cookie clicker, for example. Who play cookie clicker? It generates all the way no capacity at all, right? Normally, if you have a puzzle game with lives, you have a capacity. You would say, like, okay, generate lives, but until 5, for example. With games like Clash of Clans, for example, you have a generator which have their own capacity, and then you have resource storage, so they fill up, they won't generate anymore, you collect it, then you can generate again, and theoretically the storages also have capacity, so in this case you collected only a fraction, not everything. This is why sometimes if your simulation is not deterministic, it is okay to send amount as well, okay? So last but not least, I'm very sorry, I will skip through these points because I don't have that much time. Let's talk about competitive farming and the synchronous PvP. Player plays against AI which acts based on other players' game state. Now we have actually real-time decision making. How can people cheat in this case? What's the common pattern is actually that people tamper with the config at either when they get the config or actually real-time memory manipulation where they say, okay, the damage of this unit is now 10 times the value that you have, and then they can swipe out everything with just one unit. And it's really hard to validate this kind of things because you have things like pathfinding, dynamic targeting, and so on and so forth, like typical AI problems which validating is hard. So for this, we have actually 2 solutions which we can have. First one is implement AI on server. So server is the authority. Your game on the mobile device is just basically sending the commands and rendering, things which we do also in first-person shooters, for example. There are issues, however, with this kind of solution. And first of all, it's network latency. We are on mobile, so people can have very crappy connections in a way, and therefore we at least have to implement prediction systems as well on clients, which is, again, a little bit of work to do. And we could also have complete network failures. And for mobile devices, this is a common thing to have, in a way. Then, if we are actually successful, we will have a huge load. You can scale horizontally quite easily, but the problem is you will have 1 player per process. If you have, for example, FPS, which can have like 18 players per process, this is cheaper to have in a way instead of a situation where you have asynchronous PvP and therefore every player would need a separate process to talk to. We don't share people on one process. And then there is this question, okay, what do we do with PvE and replays? Do we also use servers for this? Or do we have to implement the AI anyways on the client? So there is always this question of, we actually needed the AI on both sides. What should we do? So there is this second solution which says, okay, we can actually do validation by replaying on the server, and we will just share the AI implementation. So make the AI shareable, and then you just have a replay. And what you do is you let user play for a couple of minutes, right? So you don't care then if they lose connection to the server because they play locally. Then at the end, they will send the initial setup, all the interaction commands, and the end result to the server. Server will just replay and see if it becomes the same final state that we send it as a user, and then if and only if, we will then just change both states for players who attacked and player who's been attacked in this case. All right. Requirement for the second solution. Requirement is basically we need a deterministic simulation. And for this, in my experience, you have like 4 pillars which are very important. It's the order has to be total. Like, we had a problem, for example, we sorted everything, and then at some points we saw still that there are diversities. We debugged and saw that our sorting algorithm, in some cases, could say things are equal. In this case, it's random which element will be picked. Therefore, what we end up doing is basically having a strict sorting where we throw an exception if we come into the case where we have equal things. Because in this case, we just basically don't have deterministic simulation anymore. Thank you. Floating point numbers, again, complicated thing, different architectures because we run on Android, iOS, and on FreeBSD, whatever we use for the servers. In this case, if you can avoid them, avoid them. If you can't avoid them, be very careful with them and test a lot. Generally, with deterministic simulation, the best thing that you can do is always try to unit test them as much as possible, in a way. Then fixed time instead of delta time. Inside of your simulation, there should be fixed time because delta time means that you are, it depends on the hardware how fast things run, right? And pseudo-randomness. So you need an algorithm which will spit out pseudo-random numbers. It should feel random for the player, but it's in reality you can replay it quite easily. All right, last project I worked on was a real-time economy, which had one interesting point that we had also contracts, but the contracts were triggered by AI. So the starting and collecting of rewards was not in the power of the player anymore, but done by AI inside of a game. So this complicates user interaction in regards to economy, specifically if you have like a multi-step something, you want to buy something, and in the beginning you have the resources, and then you have multiple steps. It could be that some refinery just will steal your resources, which is bad experience for the user. So you also have to basically reserve the resources when you start, and then if they cancel, then you just give back the resources that you reserved, and so on and so forth. So when we were working on this game, we thought about, again, how to achieve double entry bookkeeping, right? And for us, it was also the case that the backend was introduced a little bit later, so half a year in the development, and we thought about like, okay, they either will need a half a year to kind of catch up, or we will go with sharing code, again, which will actually as well enable us to evaluate on the game much simpler because you just have this one simulation which is shared between client and server. How did it work? So we have this client here, we have the server, which now have no logic at all. No gaming logic, basically. It's just a broker between the client and the stateless worker. The stateless worker have the AI, basically, which is also on the client, and it will run this through. Okay? So in this case, what we had, again, we needed deterministic simulation, but we were already kind of prepared for this because we had it in different games. And the other thing which came up was efficient data serialization and deserialization. This was needed Basically because if you just replaying a battle, this is not chatty. Just send like 3 minutes of gameplay and it will be run. But if it's for everything that you do in the game, in this case, serializing and deserializing JSON as we had it before was too expensive. So we measured it, we had like 60 milliseconds for JSON deserialization. It was like 50K of game state and 400K for config. And then we switched to flat buffers and we went to 2 milliseconds, which actually was quite nice. Why did were we able to achieve such a big gap between serialization and deserialization? Quite simple, because like normally what you do, you load data into RAM, you make data accessible. So in case of JSON, XML, and so forth, it means parsing. And then you can directly read values if you have a config, for example, or you transform data if you have game player state. In case of flat buffers, this step is zero cost. All right, recap. Concepts of mobile simulation games. We have context, we have resource generation, and we have asynchronous PvP, in a way. Then concept behind server validation. Main concept is double entry bookkeeping. And then we say we can either re-implement the simulation on the server, or we can share code between server and client. And efficient data serialization and deserialization is actually a really interesting thing that you maybe should think about if you implementing such games. All right, thank you very much.
Hello. You mentioned that you apply results only if client and server agree. Exactly. Why do you not just let the server win?
The point is, in the case of the battle, there are two parties involved, right? Mm-hmm. So if you see that the client cheated in a way, why should you bother to kind of give cheaters anyway anything, or give the person who was attacked something? In this case, you can just discharge the whole simulation and say, okay, there was nothing. Don't bother to, like, you could actually reward the one who was attacked, but why? And there is no big meaning of punishing the guy who tried to cheat in the first place. So, yeah. You could punish them then to say, like, okay, you're cheating, therefore I would like to actually do some nasty things to you. Yes, but not necessarily.
Do you have false positives?
You could have, yes, and this is what you would have to, like, if the simulation is deterministic, you shouldn't, right? But again, you could have bugs. This is why we always kind of pre-record things and then we make tests out of them and rerun them again later to see if there was some complaints. We would be able to make it as a regression test, run it through the simulation again, and see that it won't happen again. So again, testing is actually a very important thing in this kind of scenario. Yes?
Did you have any problems with desyncs, like difference between the client game state and the server game state?
Not necessarily. Like, the point is, the interesting part is basically, specifically, when we went all the way in the real-time simulation, it could be that actually the books are not synced, and the server will only complain if, for example, I say, I just wanted to purchase something, and the server says, like, you don't have the resources for this. In this case, the server will just say, like, okay, reset to the following state to my book, in a way.
Yeah. What I'm thinking about is during development, when you add new features,
yeah,
then desyncs and debugging those, like, was that a problem? Like, did you make tools to make it easier?
Well, not necessarily, I would say. Like, basically, again, what you would like to do is first write a test for your new feature and see that you kind of that your validation still works as you think it's supposed to work, and then at some point, and it also helps you to debug the whole simulation, because, like, again, debugging an isolated test is quite nice compared to if you're trying to kind of run through the whole game and like trying to achieve this kind of result. So this is kind of like try to isolate your logic of your simulation as much as possible, and therefore should be okay.